And now the question, why we use logarithmic in entropy? And that's an important question to understand. Okay, so we use the logarithmic function because usually the logarithmic, it quantifies the information content. And we use the base of 2 because it reflects the binary encoding in bits. Now in probability we have also 0 and 2. In communication, when you send bits, every bit can be 0 or 2. So look at the relation here. The equation is that we're using, it's the sum of the product of the probability multiplied by the log of that probability. And here we can observe a relation between the probability and the log of the probability. When we have a high probability, what does it mean, high probability? It means high certitude and less unpredictability. So in this case, the logarithmic of 2 of that probability is going to decrease. Okay, I have less information. P of x is high, it means I am more confident, it's less unpredictable, it means I have less information. If P tends to 0, the amount of information will be high, okay, because it will be highly unpredictable. Okay, and look now, we draw, this is a simple Python code that draws the probability in the x-axis and also the information content in the y-axis, which is calculated by minus MP of log2. Okay, it's only log2 here. And they are inversely proportional. Okay, it's decreasing. Okay, when the probability is high, I will have information equal to 0. And when the probability is low, the information is going to tend to infinity. Okay, and this is why we use the product. So you have, when the probability is high, the information is low, so it's going to tend more toward 0. Okay, so it's like a weighted product of the information. So I'm going to weight the information content with the probability. And we are going to have the sum of the weighted information, which will give me the whole information. Okay, so every bit, every outcome will give me a certain amount of information, and the whole entropy will be the sum of all this information. So I'm going to have like an average about everything going on that particular model. Okay, so certain event P of x equal to 1, they lead to no information as we already introduced. So the reason of using logarithmic in the entropy is because logarithmic in entropy articulate how unpredictable translate into information content. It's this relation basically. And this highlight the inverse relationship between probability and information gain. Is that clear?
Why can't we use different bits?
Because you have bits, 0 and 1. That's why. And this is now, I'm going to explain why we use the logarithmic of 2. So the entropy started in the communication context. And in communication, we use binary values, 0 and 1, okay, in digital information processing. Everything we are going to convert it into bits. Okay, this is even in digital logic. Okay, everything is binary. We transfer every number to binary. And the log2 of n, it calculates the bits needed to send n distinct messages. Okay, so for example, if you have 4 messages to send, you have 4 outcomes. In this case, you will need 2 bits. So the logarithmic of the logarithmic at base 2 of 4 will be equal to 2. And this is a simple Python. If you have 1 outcome, 2 outcomes, 4 outcomes until 256, it will calculate the number of bits. So this is why if you want to represent a 256 numbers between 0 and 256, you're going to use 8 bits. Okay, so the log2, it encodes the amount of information that we would like to encode. This is why it's related to data encoding, okay, in digital logic and in communication context. Okay, so the uncertainty reduction quantification, the information reduces the uncertainty about the sent message. And the logarithmic of base 2 measure this reduction by representing the information as binary questions. So instead of having 256 values, we're going to have a combination in 8 bits, okay, values in the binary context. Okay, this is just the Python code. We calculate the outcome, okay, using calculate bits, and this returns for 1 bit, for 2 bits, for 4 bits, until 256 we have 8 bits encoding.